The sun, our life-giving star, harbors a potentially civilization-altering threat. This ever-present body, the sun, is often seen as the source of life. Its golden rays nourish the earth, fuel photosynthesis, and warm our planet, creating a delicate balance that supports life as we know it. But the sun is not just a benevolent giver of life, it's also a fiery furnace of unimaginable power, capable of releasing vast amounts of energy in the form of solar storms. These solar storms, with their spectacular solar flares and explosive coronal mass ejections, are more than just cosmic light shows. They're torrents of charged particles hurled into space at mind-boggling speeds. When these storms are aimed towards Earth, they can interact with our planet's magnetic field, leading to a variety of effects ranging from beautiful auroras to potentially damaging disruptions. The sun's power extends far beyond its warmth and light, into realms that can affect our very existence. Solar storms, a spectacle of nature, are more than just a cosmic light show. Now let's delve deeper into the science behind these celestial phenomena. Solar storms, also known as geomagnetic storms, are essentially disturbances in the magnetic field that surrounds our Earth. They are triggered by solar flares and coronal mass ejections, or CMEs, which are both explosive releases of energy from the sun's surface. Solar flares are sudden flashes of increased brightness on the sun, often observed near its surface and in close proximity to sunspots. These intense bursts of radiation are ejected into space at light speed and can reach Earth in just 8 minutes. While this radiation cannot pass through Earth's atmosphere to harm life on the surface, it can disrupt satellite communications and navigation systems. On the other hand, coronal mass ejections are much larger eruptions that send billions of tons of solar particles into space. These particles, traveling at a slower speed, can take up to 3 days to reach Earth. When they do, they cause a shock wave that interacts with Earth's magnetic field, producing spectacular auroras, but also potentially causing significant disruptions to power grids and electronic systems. So what causes these solar flares and CMEs? The answer lies in the sun's magnetic field. The sun is like a giant magnet, with a magnetic field that is constantly changing and shifting. When lines of magnetic force become twisted and tangled, they can suddenly snap and realign, releasing huge amounts of energy in the process. This is the energy that powers solar flares and drives coronal mass ejections. Understanding these solar phenomena is crucial for us. They remind us of the enormous power and energy of our sun and how its activities can impact our daily lives. They also offer us a glimpse into the workings of other stars in the universe, helping us to better understand our place in the cosmos. These celestial outbursts are not just fascinating to observe, but they are crucial to our understanding of our place in the universe. The Halloween storms of 2003 serve as a stark reminder of the sun's unpredictable nature. As we delve into the past, we find ourselves in the last week of October, 2 decades ago. The sun, our seemingly serene celestial neighbor, had a surprise in store for us. The week was marked by intense solar activity with a series of solar flares and coronal mass ejections. As these charged particles hurtled towards Earth, they carried with them the potential to disrupt our technology-dependent lives. And indeed they did. Satellites, our eyes and ears in space, bore the brunt of the storm. Communication systems were disrupted, satellite-based navigation went haywire, and even power grids experienced fluctuations. The Halloween storm served as a tangible demonstration of the sun's power, a power that could bring our modern world to a standstill. But it wasn't all chaos and disruption. The Halloween storms also brought with them a spectacle of nature's beauty, painting the sky with vivid hues of the aurora borealis. As far south as Texas and the Mediterranean, people marveled at the dancing lights in the sky, a rare sight in these regions. However, these mesmerizing lights were a stark contrast to the invisible chaos unfolding in our technology-driven systems. The Halloween storms were a vivid reminder of the two faces of solar storms, the visible, awe-inspiring beauty and the invisible, potentially disruptive power. As we reflect on the Halloween storms, we see a clear picture of our vulnerability to solar activity. Our modern world, built on a foundation of advanced technology, is at the mercy of our life-giving star's unpredictable nature. The Halloween storms were a wake-up call, a stark reminder of our vulnerability to the sun's fury. As we continue our journey through the cosmos, we must remember the lessons of the past, preparing ourselves for the celestial challenges that lie ahead. Imagine a world brought to a standstill, not by a global pandemic or a war, but by a solar superstorm. A rather chilling thought, isn't it? This isn't a plot from a science fiction novel, but a very real possibility, a silent, invisible menace from our life-giving sun. Let's delve into the potential impacts of such an event. Picture this, a colossal wave of charged particles, unleashed by the sun, hurtling through space at unimaginable speeds. This is a solar superstorm, a force of nature that could have profound implications for our modern world. Our technologically driven society is heavily reliant on electronic systems. These systems are surprisingly vulnerable to the effects of a solar superstorm. The onslaught of charged particles can induce unusually high currents in our power grids, potentially causing widespread blackouts. Imagine a world without electricity, no lights, no internet, no smartphones. We would be thrust back into the dark ages in a matter of hours. Satellites, the silent workhorses of our global communication system, are also at risk. They're exposed to the full fury of the solar storm out in space. A potent superstorm could damage or disable these satellites, disrupting everything from GPS navigation to weather forecasting to telecommunications. Even our planes are not immune. Transpolar flights, which often take the shortest route over the North Pole, could be exposed to elevated radiation levels during a solar storm. This could pose a risk not only to the aircraft's electronic systems, but also to the health of passengers and crew. But don't just take my word for it. Hear it from the experts themselves. A solar superstorm is a low-probability, high-consequence event. It may not happen often, but when it does, the impact could be catastrophic, warns a leading space weather scientist. We need to be prepared, urges another. So what we're facing is a potential global blackout, a disruption of our communication systems, and a significant threat to air travel. A solar superstorm could plunge us into a new dark age, a world without technology as we know it. Are we ready for this invisible menace? Preparation and prediction are our best defenses against the sun's wrath. As we find ourselves grappling with the vastness of the cosmos and the power of our life-giving star, it's essential to understand that we're not entirely helpless. Around the world, governments and scientists are pulling together resources and intellect to predict and prepare for these solar events. At the forefront of this mission is the science of space weather forecasting. It's akin to predicting the weather here on Earth, but with an added layer of complexity. Forecasting solar storms involves tracking the sun's activity, identifying potential threat points, and predicting how these might interact with our planet's magnetic field. The United States National Oceanic and Atmospheric Administration, or NOAA, along with NASA, operate a fleet of solar observatories and satellites. They are our eyes in the sky, providing continuous monitoring of the sun. Data from these sources is analyzed by space weather forecasters who predict potential solar storm activity. Their work is vital in giving us a heads up when a solar storm is inbound. Internationally, there's collaboration too. The European Space Agency operates the Solar Orbiter, a mission dedicated to studying the sun up close, while Japan's Hinode satellite offers high-resolution imagery of solar activity. But prediction is just one part of the equation. Preparation is equally vital. From hardening our power grids to making our satellites more resilient, efforts are underway to mitigate the potential impact of a solar storm. The stakes are high, and the cost of non-preparation could be catastrophic. Education also plays a key role in storm preparation. By informing the public about solar storms, we can promote a better understanding of the phenomenon, its potential impacts, and the steps we can take to protect ourselves and our technology. By studying and monitoring our sun, we equip ourselves with the knowledge to mitigate the potential disaster brought by solar storms. So as we gaze up at the sky, let's remember that we're not just passive observers in this cosmic dance. We're active participants, bracing ourselves for the next solar performance. The sun doesn't discriminate. Its storms could strike anywhere, anytime. This life-giving star of ours is unpredictable, and so we must be ready no matter where we are on this blue marble we call home. Global preparedness for solar storms is not just a necessity, it is an urgency. Investment in research, understanding the science behind these solar phenomena, is paramount. We need to develop cutting-edge technology and improve our space weather prediction capabilities. But this is not a solitary endeavor. It is a collective responsibility, an international cooperation. Countries across the globe must come together, pooling resources, sharing knowledge, fostering innovation. Because when the sun throws a tantrum, it doesn't see borders or boundaries. Solar storms pose a threat to our modern civilization, to our way of life. But with global preparedness, we can transform this threat into a challenge we are equipped to meet. Together, we can brace ourselves for the sun's invisible menace, ensuring that our civilization thrives for generations to come.